This playlist collects together and organizes the individual component modules for the third and final lecture on inferences and human inference abilities, covering that material from our chapter number 5. We'll start this lecture out by reviewing some of the important notions that we talked about in the first 2 lectures. Once we've refreshed those ideas in our mind, we'll turn our attention to native deductive abilities, inabilities, and biases. Once we discuss native deductive abilities, then we'll turn our attention to that second component of System 1 inference strategies, those context-dependent inference strategies, looking at examples of both deductive and inductive context-dependent inference strategies. Then we'll finish this lecture by trying to put what we've learned into focus, trying to come up with an overall understanding of its significance. Let's turn our attention then to that first bullet point. Let's talk about some of these important features that we discovered in the previous 2 lectures regarding our native reasoning abilities. So we'll start off by discussing those 2 inference strategies that emerged in the previous lectures, System 1 and System 2. And we'll talk about their typical deployment and their interrelationships. Then we'll remind ourselves about the things that we learned by considering the evolutionary origins of human inference and decision-making capacities. Namely, that humans and proto-humans spent this very long period of time, this hunter-gatherer period of time for 4.4 to 4.7 million years, in which they were solving problems in a relatively stable, relatively homogeneous, relatively small environment. And the sorts of problems that they were solving were largely reactive, concrete problems dealing with specific objects and relations in their immediate environment. Then we'll remind ourselves about deductive inference a little bit. We'll remember that deductive inference is a type of inference that maximizes the preservation of truth across that inferential transformation. So that if we start with true initial information and engage in a good deductive inference, the resulting informational transformation gives us information that is also guaranteed to be true. Because of that emphasis on truth, we realize that deductive inference is non-amplitive in nature. It doesn't extend or increase the things that are guaranteed to be true. It merely takes things that are already guaranteed to be true, given what we know, and makes them explicit. And finally, we'll notice this relationship between content, which is readily accessible and highly salient to our native inference abilities, and underlying logical structural relationships in deductive inferences, which are relatively opaque, difficult for us to represent and take account of in our intuitive native deductive inference practices. Finally, we'll look at our intuitive capacity to formulate and evaluate deductive inferences, focusing in on the fact that this capacity is, as consistent with System 1 strategies, highly contextualized. We'll recall that cognitive scientists grouped inference and decision-making processes into 2 systems. They aren't brain systems, they aren't dedicated anatomical components of our brain designed to do these particular things. They are merely collections of brain processes for making inferences and making decisions that are grouped together by cognitive scientists because they share a set of properties, a set of features that make it useful to think of them as sharing a common approach, a common strategy to processing information. Now, the first property that we find associated with System 1 processes is automaticity. They are automatic reactions to situations. They are not things that we consciously will or choose or decide upon. They are reactive in nature. The second feature that we see with System 1 inference strategies and decision-making processes is that they are autonomous. That is, they operate relatively independent of working memory. And for that reason, we don't have a lot of conscious awareness of their operation, insight into how they operate, or oversight into whether they should operate or how we execute them. But on the positive side, the operation of System 1 processes occurs at the relative same level despite differences in fluid intelligence, so that everyone is just about as good at these System 1 inferences as everyone else. Third feature of System 1 processes is that they are highly contextualized. The information that they rely upon, that they draw upon most heavily to execute those inferences or make those decisions, is information about the content of the problem at hand and the context, the way in which the problem is presented in the situation at hand. System 1 processes operate associatively and in parallel. That is, they tend to leverage associations between content items within a problem, and they tend to process information all at once as opposed to a sequence of processing steps. They tend to be relatively fast in comparison to their System 2 counterparts, and they tend to be capable of processing larger and more complex bodies of information than their System 2 counterparts. System 2, again, doesn't refer to a specific brain system, but rather identifies a category of inference and decision-making processes that share a common set of properties that identify them as a particular strategy for processing information, a strategy that is distinct from System 1 processes. The most prominent feature probably of System 2 processes is that they are non-autonomous. They draw heavily upon our working memory resources and require working memory in order to operate. And so for this reason, there is always an element of conscious awareness that we're using a System 2 process, conscious oversight in the selection of the process or execution of the process, and conscious insight into how the solution was generated. Because they rely on working memory, differences in fluid intelligence working memory capacity result in differential abilities with regard to these System 2 processes. Because they rely on working memory, System 2 processes oftentimes are relatively difficult to engage, in part because they require that we have excess working memory capacity in order to be able to evaluate a problem and then to determine a particular strategy and then execute that strategy. And so for this reason, oftentimes, even when people learn System 2 strategies, they don't employ them in relevant situations unless the context cues them, indicates to them that this situation is that kind of problem. So for instance, we'll oftentimes find that physics students will fail to use basic physics to solve problems where that basic physics obviously applies, unless the situation is such that it reminds them that this is a problem that should be solved using physics. Statistics is the same way. Even economics professors will oftentimes not use statistics to solve problems where statistics could be quite useful unless the context cues them to identify this as a problem that statistics will be relevant for. These System 2 inference and decision-making processes, particularly the ones that are learned and passed down culturally, tend to be highly decontextualized. That is, the information that drives these processes tends to be underlying structural relationships that are definitive of the nature of the inference or decision-making problem and that are constant across different instances of that problem. They often are learned from one person to another, taught by one person to another, passed on as part of a cultural heritage. So we think of this relationship between our System 1 and our System 2 such that we are biologically biased or predisposed to rely much more heavily on these System 1 processes. These System 1 processes operate automatically. They're like that train that's running down the track very quickly, very rigidly. And our System 2 processes are like this engineer on the train, capable of recognizing when there are troubles or changing direction or speed of the train, but they aren't really competent engineers. They are engineers that are limited in their capacity to perform that oversight function.